So let's get started. Welcome everybody to this second meeting of the Beyond Spacetime group here. And I'm very happy to present Michael Esfeld from neighboring Lausanne, whom many of you know already. He will be talking about relationalism, about space-time and the essence of matter. So please, Michael.
Yeah, hello. Thank you very much for having me here. Now, I'm not sure how shall I manage it. I can't see the people from Chicago, but I'm not supposed to see them.
Why not?
Okay, I see Nick. Hi, Nick. Okay, do you see me?
Yeah, we see you.
Okay, so if I stand here, everybody sees me at this and the other side. Okay, I'm not used to this way of talking either, but we try to do our best. So what I want to do is just to throw at you a proposal for fundamental ontology. That is an ontology which you cannot reduce to anything else, and which should be empirically adequate. So it should do the job of describing the real world as it is. And the proposal is on the next slide, I hope, if this goes on. So the proposal in any case is that there are just points. These are meta points. And why are they meta points? Because they stand in spatial relations. So what you have is a spatial structure given by spatial relations, and that spatial structure individuates your objects. These are point objects related by these relations. And then you have change in these relations. And the change gives you a dynamics, and for that dynamics you need the laws, the dynamical structures, I want to call it, so the spatial structure and the dynamical structure. And the dynamical structure is expressed in a physical theory by parameters like mass, charge, energy, fields, constants, wave functions, etc., what have you in a given physical theory. You can put this proposal in terms of unionism. That would be, I'm not committed to unionism, but it would make this easier for the time being. So you can think of the meta points related by spatial relations as the Humean mosaic. That's what's out there in the world. And a physical theory is finding a physical theory of that mosaic is the business of finding the description of that mosaic which passes the test of being simple and being informative at the same time. So the geometry and the dynamics then come in as a package as being the most simple and informative description of that mosaic. But they are not out there in the world. What is out there in the world are only spatial relations, relations of spatial distance, relating points. There's individuating points and making it that the points are meta points. They're meta points because they stand in spatial relations. These spatial relations change, and that's all there is that there is in the world. And all the rest is your exercise in describing what there is. So why should you believe such a theory or take it seriously? Well, it's most simple. You cannot do this less, and it's most general. And it is empirically adequate. It is most simple because if you take away the spatial relations and or take away the points, you're left with nothing, and there is something in the world. It is most general because it covers everything, and it is empirically adequate. It is able to explain all the experimental evidence. Why? Because all the experimental evidence that we have, at least what we have in physics, is particle positions and particle motion. And all the rest, fields, you may think of waves, masses, charges, forces. That's an experiment, forces here. They come in as a description of this particle motion which passes the test that we had before. And I claim that this proposal covers all known physical theories from quantum mechanics to quantum field theory. Whether it covers unknown physical theories about some people's work, like my hosts, I don't know. But you know, want to see these theories, the physical theories, how they work, want to see how they do the job of being simple, being general, and covering the evidence. Okay, you may say, of course, we have more evidence than just particle position and particle motion. We have evidence of tables, of walls against which you can run, etc. But then I simply take for granted that when it comes to such higher level entities that are composed of these basic physical things, atomism will do the job. I mean, atomism in the sense you have atoms, how do you do, you're working on how do you do these emotions, you have here neuroscience, you have, they study the brain, so what is the brain? This is a configuration of neurons, what are neurons? These are molecules, what does biology study? They study molecules, the direction of molecules, what are molecules? Molecules are composed of atoms, so in the end then the question is what are the atoms, what are the basic building blocks of the world, and then the claim is what remains of them is that they are point-like entities, and or there is to them the spatial relations among them. So that's the program, or that's the claim, that's the most, that this is, I mean, in real life, after this talk, you have another seminar, I understood, then you will have dinner, and for dinner you should have more than bread and water. But for philosophy, bread and water, so points, basic relations between these points and the change in these relations will do. And in philosophy it's better to have a meager diet because you need an argument for having more. So in brief, less will not do, that's the claim, and bringing in more will create problems instead of adding explanatory value. So you could bring in more. Why should simplicity as such is not so good an argument? Because you could say, why should it be simple? If you enrich your ontology and if you can explain more, then you gain something. But then I would deny that you really explain more, and you would get problems. So for instance, you can talk about absolute space. When you bring in absolute space, you get certain problems. You get the problems Leibniz pointed out against Newton. You get the problem to come up with a distinction between space and matter, etc. When you bring in intrinsic properties that are supposed to individual objects, and these properties do something, you have the problem how can one property reach out to another object. When you bring in fields in your ontology, you get a problem how the fields and the particles interact, etc. And if you only have the spatial relations and point-like objects, then you don't get into these problems, because you just I mean, if you want to have a rich dinner, then you have to choose the best combination. Will you have the salad before or after the main course, etc. And if you only have bread and water, you don't run into problems how to bring salad and main course and these things together to start with. Okay, so that's the general framework. Now, this I'm supposed to talk about, or the framework of your project is called something like the emergence of space-time, and of course here space does not emerge.
The temporal project is called Space and Time After Quantum Gravity.
Yes, so then this talk is about space and time before quantum gravity. Okay. Because I don't know the physical, I mean, the philosophy of unexistent physical theories and what comes after, then I'm not so sure about. Okay, so one last word about this general issue. So of course I'm not a positivist. So you can say if you do Quine, if you look for the ontology of physical theory and think you get it by just putting the theory into first order logic, then of course you quantify over a lot of things which are not in my ontology. But I would say, why should one do this? I'm not looking for the ontology of a particular theory. I'm an empiricist, so the data, the empirical data that I have, they're not sense data, but they are something like, as I said before, you have the experimental evidence in physics, particle positions and particle motion, so I shall get that experimental evidence right, so that's what I wish to explain, and then I have to fix my explanans according to what I want to explain. So the physical theories are there to explain these particle positions and particle motions, and they bring in a lot of further stuff, but that does not mean that by having such a physical theory I should be committed to that further stuff. It's just a question whether whether that further stuff is necessary to do the job, and whether it not brings me into trouble. Okay? So now we should, this is just the general framework, and of course you can, so it's a philosophical talk, so we can talk about this, whether it does the job, but now just focus on spatial relations and the issue whether spatial relations are fundamental or not, whether they are emergent or not. So for the time being, I'm happy, or as long as I can be, I would like to be a Leibnizian. So I would like to take Leibniz, what Leibniz says about space and time as literal, and uphold this as literal as possible. So first, for Leibniz, space is the order of coexistence. Why can he say this, or what sense does this make? You have a plurality. If you want to have an empirically adequate theory, you should have more than one object. There's more than one object in the world. There's variation in the world. Now, the spatial relation, by ordering the objects that you have in the world, gives you variation. They are distinct, these objects, but because they stand in different determinate spatial relations of different distance. So if we just were points, we are I'm now 1 meter away from Olivier Masson, so quite close to him. Philosophically, we may not be that close, but later tonight we will be further apart. So our spatial relations change, and we are two objects. Why are there two objects? Why are we different objects? Well, in the end, because we stand in spatial relations that distinguish us. Or at least the claim is the spatial relations are sufficient to do the job. They can, unless one excludes, one then better should exclude than certain symmetrical cases in which the spatial relations do not distinguish, but I don't need the mathematical surplus, I don't need them for the real world. I can stick to Leibniz's principle of the identity of indiscernibles. So the spatial relations are sufficient to give me variation, to give me distinct objects. And now the claim is, are they necessary as well? They are necessary in the sense, not in the sense that I have an a priori metaphysical argument why spatial relations should be there, but they are necessary in the sense that there's no other relation that comes to my mind that could do the job as well as the spatial relation does. So you get, in a certain sense, you get emergence of space. In the sense that space emerges from spatial relations. In the sense that space emerges from those relations that individuate your objects. But these relations are spatial in the sense that there's a primitive spatial distance between any two objects. It's three-dimensional. That's also sufficient. You don't need more dimensions for empirical adequacy, and you cannot do with less dimensions. So the three-dimensional spatial distance is necessary and sufficient. And now, if you ask me, could we do with other relations than spatial ones from which space emerges? In principle, we could do, but they should meet these criteria that they give you variation, order of coexistence. So what gives you the order of coexistent objects? What gives you the fact that you have more than one object? And I would not like to, unless forced to do so, to have to accept that fact as primitive. The spatial relation does the job. It gives you more than one object, because there is a non-vanishing spatial distance between the objects. I stipulate this as my primitive relation. And it does the job of accounting for the experimental evidence. This experimental evidence is motion of objects, motion is change of their relative positions, so it does the job. Why shall I have? So I would say, I don't have any a priori metaphysical argument why you need spatial relations as fundamental. I would just say, unless there is some other proposal which does that job as good as well as the spatial relations do, I would stick to that proposal. So the burden of proof, I would shift it to you guys who think that some other relation can do that, and then I want to see that as a relation that it has the same fares as well with simplicity, empirical adequacy, generality, etc. Okay? So that's briefly the argument, why do you need space? Because space gives you, as Leibniz says, order of coexistence. So I would like to have order of coexistence because I would like to have a world in which there are several objects. How do I get these several objects? If intrinsic properties cannot do the job, there's a long story to be told, a long story of arguments, from structural realism, by intrinsic properties cannot do the job. It has to be relations. You have to be structurally individual. Which relations? Dynamical relations can't do the job. The dynamical relations, if you think, for instance, you could think quantum entanglement may do the job. But quantum entanglement is something that is defined in quantum physics on configuration space, wave functions entangled in configuration space. And the configuration space just is the space of the configurations of objects in the physical world. So it's a mathematical space, each point of which represents a configuration of objects in the world. So the entanglement cannot give you the plurality of objects in the world. It is already there. The same with masses or charges in classical physics. They are parameters which are introduced in the theory as that what changes or what accounts for the change of velocity of these objects. So in the first place, you have these objects and you even have the velocity in classical physics. So the dynamical relations I know won't do the job. So it remains you need some primitive, fundamental relations, and the spatial relations do the job. That's why I'm skeptical about emergence of spatial relations, because I don't see from what they could emerge. Okay, so move on to time. Leibnizian. Okay. You have the fact that the world is interesting. The world could just be one configuration of objects that don't change, but that's not what the world is like. Every exciting, every interesting thing about the world is that there's change. Change in what? Change in the spatial relations. There's motion. So if I move closer to you, it just means that our spatial relation changes. And that's all the change there is. All the change that we have in physics is not some qualitative change, intrinsic change of objects that we explain in terms of molecular biology, etc. So we explain it in terms of physical entities, and these physical entities, these physical objects, they move. They are matter in motion. Okay? So you get change. So you get a stack of such configurations. I had that on an earlier slide, sorry, not as well ordered as they could be. So you get a stack of such configurations, one configuration, next one, etc. And this doesn't mean that you have one absolute starting point. This can go on down there as long as you want and up there. Now you have to order them. And Leibniz says time is the order of succession. And he says that the order as such, order of succession, that it is unique. So this configuration comes before that and that one. I could not put that one on the top and that one here. Then the order would no longer be unique. So it's unique. And it has a direction. Okay, first that one, then that one. So that's why, that's what defines time for Leibniz is that parameter that orders, that poses an order on the change of these configurations. So you could represent these configurations by points. You construct a mathematical space. Each point of that space represents spatial configurations in the world. Then you have several points in this space. You have to connect them. You have to find a curve on that mathematical space. And now the claim is when you designate one configuration as your initial state of your universe, one as your final state of your universe, then there is a unique path in that configuration space which gives you the way from the first configuration to the last one. Okay? So it's unique, it has a direction. So we get a topology, we get time out of that. That's what defines time. The uniqueness of the order and the directedness. So we get a topology of time out there that is absolute. It's clear which configuration follows which one. But the metric, of course, I would say, of course, is not is not absolute because there's no external clock. So it makes no sense to ask the question, how fast does the change from one configuration to another configuration go? Or if we start with one and end with another one, how long did the world last? This makes only sense once you define subsystems in your configuration as clocks, relative to which you measure the change. So the metric of time is relative. It depends on the choice of a subsystem with respect to which you measure duration, but the topology is not relative. That's what I take the Leibnizian claim to be. That claim is compatible with what is known as the B series of time. Some configurations are earlier than other configurations, later than other configurations, and it's also compatible with the A series view of time. You can designate, the theory allows you to designate one configuration as the present one and order all other configurations as past or future one with respect to that configuration. So it's compatible with the A series, and then it's also compatible with presentism. You can take the view that only one such configuration exists, and you can take this view, let's say you can take this view, I'm not sure whether I should take this view, but sometimes I like presentism, at least, yeah, I like it, I don't take it to be excluded, I'm not sure whether that's the right way to go. Okay, and that can be such even if the dynamical law is such that when you write down the law, you need parameters, so you want to know how the evolution of the world goes on. So the law may be such that it helps you to know how the evolution goes on. Now you need parameters from past configurations, if there's retarded action, and you may even need parameters from future configurations, if there's advanced action. But this does not rule out that only one configuration, namely the present one, exists. So we are not yet into laws here. I think whether this issue about presentism, A series, B series, that should be defined on the level of what some people call the primitive ontology. The ontology where you have what you accept as primitive spatial relations and their change, in order of their change, and the law is then a representation of that change which comes in later. Okay, so that's a quite strong view of time. So in a certain sense, again, I can say time emerges. Yes, of course, because time, there's no absolute time. Time emerges from change. If you had a configuration in which, if this came to an end, or if God were so nasty it never let start, then you would have no time. If you just have a stationary configuration, you would have time. So time emerges from change, but the order of that change is such that it is unique and has a direction, so you have time automatically as the order of that change. And now you could start to negotiate. You may wonder whether you need the direction of time. Perhaps you don't need it. You could think of the direction of time coming from special features of your initial configuration. So it may be that the initial configuration is one with very low entropy, and then entropy increases, that the dynamics is such, the dynamical law is such that entropy increases, and perhaps you get the direction of time from the increase of entropy. I'm rather skeptical about this, but perhaps it may be possible. So you could negotiate abandoning the direction, then you would abandon the A series view of time and also the B series view of time, because the order which is given for these configurations would not be such that that it is an order according to earlier and later. Earlier and later then comes from the error or from the thermodynamic error, but it would still be unique. And I think the uniqueness you cannot abandon. So if you have your stack of configurations as I had before, as I kind of before, and if there's no unique order, and then you could order them as you want, so then you have 1, 2, 3, 4, and you could 4 here, 3 here, etc. Then it seems to me there's no time left, and I don't see how you get empirical adequacy. So at least you need a unique order and probably also a directed one. So time comes in as soon as you want to order configurations. So, and some, you know this, I'm skeptical about emergence because I'm quite happy with Leibniz. I think Leibniz's view of space and time gives us all we want and all we need. It gives us variation within the configuration. So you want to have a plurality, your world, your universe should be a plurality of objects. Spatial relations do this. They individuate the objects. If you stipulate that the distance relation is such that no object stands in all the same distance relations to all the other objects in your configuration of objects. This, of course, implies that you need at least 3 objects, so worlds with 1 or 2 objects are simply ruled out as a symmetrical worlds. But this doesn't bother me because the real world that I want to capture is neither symmetrical nor does it contain only 1 or 2 objects. Okay, so the demand is I need some relation that gives me variation, that distinguishes my objects. As I said before, the spatial relation does the job. I'm simple-minded, so I don't know any other relation which does the job as well. But if you tell me that there's another relation which does the job as well, okay, that may be so. The second thing on which I want to insist on variation to get a plurality of objects, and I want to insist on change, otherwise I lose my empirical adequacy. So change, indispensable, change in what? Well, change, and that's what gives you the variation. So change in the spatial relations, and then I need some order for that change. And again, then time, because the order, with the order being unique and directed, does the job. And again, the question is, could something else do the job as well without losing empirical adequacy? Again, I don't know any other candidate, at least not worked out, that could do the job as well. Okay, so I have claimed up to now I have spent, we are well on time, so I've spent 30 minutes. I wanted to spend about 15 minutes on the general proposal. I wanted to spend about 1/3 on telling a bit, because this was what I was supposed to do about space and time and just voice my skepticism. I mean, being a Leibnizian, I don't think that there's an absolute space and absolute time, but voice my skepticism about spatial and temporal relations coming out of something that is not spatial, it is not in some sense spatial and temporal from the beginning. And what we can do in the time that is left, the third part, is make a very, very fast, a very, very quick run through physical theories, because I claimed that this is necessary and sufficient, that this meager diet of just having spatial relations and their change is sufficient to do all known physics. And of unknown physics, I don't know anything. So it's sufficient to do all known physics. How can I do it? So what I need, what's the job of a physical theory? Now I could do this in the paper which was distributed by my postdoc Antonio Vassallo. He has developed formalism, etc. So we start with spatial relations, and then we somehow you can represent them. So after some steps, you get to be able to represent them in a Euclidean space. So suppose that the relations, the distance relations, are such that that they allow for representation in Euclidean space. This has certain advantages. This has the advantage that you can now focus, that you can now pick out one meta point and say, that guy shall be my reference point. That guy shall be such that I put an origin of a coordinate system in there, and this makes my life easier, because to describe my configuration Q, then I only have to describe the configuration of n particles. I only have to describe the relations with respect to the particle that I single out as my reference point, so I can do with n minus 1 relations to that point. So I put this, etc. So that helps to do my job. It's not necessary that the geometry be Euclidean, etc., but it is, for the purposes we are concerned with now, it will do. What what I then need for dynamics, if this is the change in the spatial relations, I need some law which gives me, if this is my configuration, then I want a law which gets me from one configuration to the next one. And we have already talked about time as the order, etc., so I can make use of the time parameter now, and then I would want some velocity. So I want the velocity will give me the motion of the object, so will give me the transition from one. We can suppose that this transition is continuous for the time being, give me the change in the spatial relations. And now, if you put this again in terms of unionism, we have, this is our union mosaic, the local matters of particular fact, the relations between the matter points. These relations change, and I could address a very long list of how these relations change, and it would not be simple. It would be right and correct and complete, but it would fare bad on simplicity. So you want to simplify. You want to be such, that's the task the physical theory has to fulfill, to be such that you fix the velocity once and for all, such that you specify an initial configuration and initial conditions at that configuration. You plug them into a law, a differential equation, such that as output you get the whole change. That's the job you want the physical theory to do. How can you do it? You observe change, and of course on the basis of the observed change you make a conjecture what that law could be, what could be to do the trick. So in more philosophical terms, what comes first is the change. You only have the change. Suppose you have the whole history of change, the whole history of the world. Then the task is, write this history now down in a way that is simple without losing too much on the information about how the world went. And then you need further parameters, so masses, charges, energy, fields, wave functions, etc., what have you. There, you can be, if I be a bit provocative about this, provoke people who work in the room who work on forces and think forces exist. No, of course they don't exist. They are just instruments. Wave functions don't exist. People make a lot of fuss about, some people make a lot of fuss about wave functions these days. No need to make such a fuss. It's clearly that they are just mathematical means of representation. Representation of what? Yeah, brief representation of the whole change. And they do the job if they are such that you specify them in addition to your configuration, put them in a law, and then put them in something that then becomes a law, and then all the whole change is fixed. So determinism comes out, but without any ontological way. Once you have a deterministic law, you know that you are done. If you don't have a deterministic law, maybe you have not done well on simplicity. So you do well on simplicity. If you specify an initial condition for one configuration, you can do all the rest. So this, let's call this the dynamical structure. And the dynamical structure, of course, varies from one theory to the next one. It does the job, and the geometry comes into the dynamical structure as well. So now you have to negotiate with which geometry and with which dynamics you achieve the task of giving a description as simple as possible. But since Nick is there, so you're all familiar, because this is just repeating what Nick, in a very good, great paper in mind in 2006, has done about classical mechanics. Okay, so that's the game. You get geometry and dynamics in a package as means of description of these things. Now you can say, and that's an argument, for instance, Tim Maudlin has this claim. Tim would say that, okay, you can live, but simplicity is not a virtue in itself. You can live, but you would gain an explanation if you add more to your ontology. So you would gain an explanation, for instance, if you have an underlying space for your spatial relations, then you would get the geometry from that underlying space instead of having to presuppose that these spatial relations are simply there, the distance relations develop in such a way. But of course the underlying space then is constructed in such a way that it does exactly the job of giving you the distance relations and the change you need. The same if you think that masses are intrinsic dispositions sitting in these objects. What is a mass? Well, a mass is what makes these objects attract each other. So you don't gain an explanation here. You put in more, you change the modal status. So if you have masses, then of course it's necessary that the objects attract each other, whereas on this view that I defend, at least for the purposes of this context, the change is just there, so it's contingent how the world changes, and the mass is just one variable that allows you to sum up this change, or the forces, or what have you, or the wave function, in a simple and informative manner. So the claim is you don't gain an explanation by adding these deeper structures, because you have to define these deeper structures in such a way that they just do the job you want them to do. So mass is what makes these objects attract each other, but the attractive motion you had before, so you don't add an explanation by saying, well, they attract each other and there's one X, which is something, of course it's the Molière objection about the virtus dormitiva. You don't add an explanation by saying that why people fall asleep when they consume opium. Well, because opium has the power to make them fall asleep. Why do the objects attract each other? Because they have mass, or they have forces, or so. What are the forces or the mass? That's what makes the object attract each other. So as I have them just as bookkeeping variables in your ontology, that's what I mean. You don't get an explanation, and you create additional problems. So if you have masses and fields and things like that, then you have to tell a story how one object reaches out to the other one, how one object that creates a field. You have to prevent the field from acting back on the object, and your theory breaks down. You get into a whole mess, so better don't get into the mess from the start. Okay, quick one, how you could do this. So in classical mechanics, you would introduce, to do the job, gravitational constants, gravitational inertial masses, which determines the force or potential, and initial velocities. And once you have this, so here it is written down in a way that you have just an equation for just the definition of the velocity, so first order instead of second order, and the definition of a potential. And once you plug this into the law we had on the previous slide, on the scheme for a law, then you get the development of your configuration out of it. You don't know the initial configuration, of course. You make a stipulation what would be the typical evolution, and you get the statistical mechanics, and then you can really do work. You can do the same with quantum mechanics. You have, of course, for this purpose, you have to adopt the particle ontology for quantum mechanics, but the argument for that is independent. So why should you be a Bohmian about quantum mechanics? Well, because the Bohm theory solves the measurement problem that plagues other people. So the argument has to be independent in this case. But once you see that way you solve the ball-boom bell way, you solve the measurement problem, then it's easy. You can do the same. You define the velocity. Now you need wave functions, but they are nothing particular. They are just dynamical parameters, and you need the equations look others. You still have, if you want to do a Bohmian gravitation theory in a non-relativistic framework, you again have your gravitational constant, mass is the potential, then Planck's constant initial wave function. If once you have this, you get your velocity field determined. If you don't know the initial configuration, you stipulate that there's a certain typical evolution, you get out the quantum statistical mechanics. You can do the same for, at least it looks not desperate to try to do the same for quantum field theory. What is, you would then have to have, of course, again, the thing gets more controversial, but it's not for tonight. Again, you would have an ontology of permanent, a finite number of permanent particles. This define a state of these permanent particles, which is your equilibrium state, so you don't see it. What then interests you is the excitations of this equilibrium state. Those you represent by what is called particle creation and annihilation operators. Of course, there is no particle creation and annihilation in the ontology, but the idea is, or the claim again, is that you can get the standard calculus of quantum field theory from an ontology of permanent particles only in the deterministic law, although the whole thing is called quantum field theory, and although the whole thing looks like particles coming out of nothing and disappearing into nothing, but there's no such thing. They just become observable under certain circumstances, fail to be observable under circumstances, and all this depends on the state of motion of the observer and the choice of a reference frame, etc. So the claim would be you can do this as well. About fields, I already said something. So again, for fields in general, you don't see fields, you see particle motion. You bring in the fields to explain the particle motion. The fields better be only a variable in the Humean best system and not in your ontology, because then you get into mathematical troubles, self-interaction problem. You get again this objection, they're going out to infinity, and you're not quite sure what fields are. Are they some sort of stuff? Are they properties of space-time points? But they are not properties of space-time points, at least not geometrical properties, etc. You get into a number of trouble. Now you can ask me, and it's a reasonable question, and I don't have a good answer to the question, so I should close with that in the last minute, what to do about relativity and what to do about general relativity in any case. And I don't have an answer, so you should have time to work on this, and we'll see. And Nick will be here early in December and give a talk in Lausanne, Nick, so you should find something that we can do with relativity. So I would just hint at two things. So again, I think also in relativity physics, the evidence you have, also in general relativity, the evidence is how certain objects move under certain influences. And the influences, including the metrical field, is what comes in as a dynamical variable explaining the motion, and you can be a Humean about that dynamical variable. You can be, and I will be, and I am skeptical about the block universe view. Why? Because I want to have, for empirical adequacy, a distinction between variation within a given configuration, order of coexistence, and change in that configuration. If I just had an ontology of a four-dimensional block universe, that would give me variation in that four-dimensional universe, but it would not give me change. So it would lose on empirical adequacy. Of course, if you push me in that way, then I'm committed to a preferred foliation in this Humean mosaic. I could take rescue to Julian Barber now, who defends also a general ontology of having only, so I should have mentioned him earlier, of course, Barber, who defends also an ontology of having only spatial relations, configurations of spatial relations, he snouts, and he has some ideas, a strategy how to get general relativity out of it, and even quantum gravity, so I could just buy into Barber for these purposes, but I'm committed, as I think Barber is, so I'm committed, as things stand, as I've presented them. I'm not so happy with it, but as things stand, I'm committed to having a preferred foliation of space-time. Of course, for the dynamics of general, for relativistic dynamics, for local action dynamics, I don't need it. But for quantum non-locality, I do need it. But in any case, if I needed to have quantum non-locality, in any case, it would not give me a contradiction, this experimental data. Okay, so perhaps I close then by conceding that the relativity issue is, I'm confident to get the classical mechanics issue, quantum issue covered with that proposal, but that work remains to be done on the relativity issue. Thank you.
So we should probably start with people in Chicago with questions.
Do we see them? Yes.
Is that the way to get?
Is that the camera around or yeah, okay. See us. Yeah, let me can you hear me okay?
Yes, I'm trying to get the different picture so that we can have everybody in the picture here, different view of Skype. So, but go ahead.
So I also about the quantum field theory.
Sorry, we lost your sound.
Sorry?
We lost your sound.
Can you hear me now?
Yes.
I wanted to ask about
Maybe the best thing is not to talk, because as soon as you start to talk, we don't hear you anymore.
I've been doing that the whole time, so I don't know. I just need to speak more quietly. Do you hear anything?
Yes?
I just shouldn't speak too loudly, maybe. Did you hear that?
Yes?
So, talking about quantum field theory. So, I mean, you addressed it, but I guess I'm not familiar with what you were discussing, what we're talking about there, really, so I didn't totally follow it.
Yes.
Let me ask you another one, anyhow. So, these point particles that you're talking about, are they actually identified with particles from atomic physics, nuclear physics, high energy physics?
Yes.
Okay. Well, which ones, I guess, is part of the question, and then I really didn't understand how you, I mean, they are created and annihilated. I mean,
No.
That's what happens in collisions. So,
No.
Well, okay,
No, look what happens in collision. I mean, but this is that would be another issue, another talk, and we are working. I mean, this team with Dirk Deckert from Munich, we are working on a paper on that, which hopefully, but you're coming here early December, okay, by that time I can send it to you. But that was not the topic. No, the idea is, that was not the topic for this afternoon, okay, so in 1 minute, the idea is you have a fixed number of particles that are permanent. Now suppose that these particles are in a state in an equilibrium state, such that effectively there is no interaction between them, at least no observable interaction between them. That gives you an interpretation of what the vacuum state is. What you can observe are excitations of this ground state. And these excitations you describe in the Fock space in terms of particle creation and annihilation. But there is no such thing as particle creation and annihilation. There are just certain forms of motion of particles, and there are notably motions that deviate from the excitations of this unobservable ground state. That's what you observe. And the difficulty, the thing is to show in a non-ad hoc way how you get from this ontology, called a Dirac ontology, by imposing not more cutoffs than anybody else has to impose who's working in this area, so by not bringing in any fishy additional assumption, the formalism in terms, the Fock space formalism in terms of creation and annihilation operators, and an account of the experimental evidence.
So, I guess I can't totally wait till December if there's anything you can say now.
Yes.
What actually happens when you have positron annihilation? And then they just don't see anymore or something?
Pardon? But no, the trouble with creation and annihilation would, I mean, the question is, what is your basic ontology?
Yeah,
You don't want any something coming out of nothing or going into nothing. At least as a philosopher, at least I would be uncomfortable with this. So if I take this literally, it does not make much philosophical sense. You get something out of nothing created, like God did, and you literally annihilate it. That's not the real story, okay? So you have to tell some other story, out of which is this created and into which does it disappear. So it comes out of the Dirac sea, that's the claim, it goes into the Dirac sea, and the Dirac sea just is a configuration of a finite number of permanent particles. And to set it out formally, of course, this would require more slides. But that's the idea. And the idea is in the literature. I mean, there are papers you can read. There's the old work by Dirac. There's a published paper by Sam Collin and Ward Stroeve from 2007, and yes, I mean, with some reservations I would have, the formalism is in that paper. So it exists. The proposal exists, and we are working on a paper which, yes, I sent it to you, but it's not, it would be, I mean, I'm a bit embarrassed now. If I go into more details, I would have to give another talk about that to convince you. And or what is the general worry? The worry is that, I mean, that you see, that you measure different numbers of particles does not impose any particular ontology on you. You have to come up with a proposal of a consistent ontology that meets the standards, first of consistent, second of simplicity, and third of empirical adequacy. And this I claim one can do. And then I add polemically that I find this talk about fields being fundamental and somehow showing particle behavior unintelligible, and the dynamics I know for fields how they should do this is rather strange. If I have just the particle dynamics, it's easier. And all the evidence anyhow is particle, as you said, it's particle evidence, although not evidence of a permanent constant number of particles. So I don't understand, I understand the worry that some people say that's not what they see. Yes, of course, but then I say, yeah, that may be so, and you have to look what is the best explanation of what you see. And then the worry may be that such an explanation is in principle impossible, but then I would say, well, at least in some form, to a certain extent, it exists in the literature, so it's not impossible. Then there may be something wrong, and that's then the argument. There may be something wrong with how the explanation goes. There may be something artificial when you connect it to the usual formalism. But these are detailed issues. So why should, in principle, this not work?
Well, I'm really not getting an argument. I'm just kind of interested in a very concrete situation where you have an electron and a positron, and they collide, and then
yes,
they're not.
And then what?
They're not.
Yeah, but you could think.
So it seems like you have two choices. If you say the particles are actually conserved, either they weren't there in the first place, or they're still there, in fact, although we can't see them.
Yes, that's the option I take. They're still there, but you can't see them, and that may happen. If you can tell a consistent story of why you can't see them because they are in equilibrium state, and expect into that state, then the question is, what is the best ontology? What are the alternatives? Does it fare better or worse than the other alternatives, or is it ruled out in the first place?
But electrons and positrons are among the particles.
Yeah, but the particles are naked matter points. They are electrons or positrons because of the way in which they move. So some matter points move electron-wise, so that you describe them as electrons. Other matters move positron-wise, etc. So that you describe that's the particles as such. They are all identical. They are numerically distinct through the spatial relations, but intrinsically they are all identical. So they are not all these whole particle species come in through the way in which they move. Again, change first, and then what you attribute to the particles are variables that help you in describing that change.
And extended particles? Protons?
No.
No protons?
Yes, there are configurations of points. Protons are not points.
But I shouldn't hog all the time.
No, I don't have anything to say.
Okay.
Guys, forget that.
Do you want to take your own questions, or should I field them?
Yeah, it depends on if you have to pose an order, it's better you do the order.
So you were saying that it is the structure that individuates the points. Is it a claim about the property of the structure, or you are saying that is what you will get from
That's what I did. They are relations.
But it's
the relations.
With the relations, it might happen that you have two distinct points that are in the same relations, same distances.
Yes, for that you need
but they
three.
are numerically distinct.
No.
Yes.
No, you need three. Yeah, you need. That's why you need three. And now you put in a third guy, right? And then they are distinct because they are.
Yeah, they are distinct.
Yes.
But
they are distinct through the relation.
Now let's say you put two extra points there.
And I have 3 points there, right? I have a universe of 3 particles.
Okay.
And they are distinct through the spatial relation. So this one is at distance, say this is a distance.
So is Michael asking about the equilateral case, as it were?
Yeah, you can put 2 extra points.
Yes, I don't want, but I just stipulate that for the real world I don't have to worry about symmetrical configurations because the real world is not symmetrical. I mean, that's a bit a bargain. Either you think either.
The thing is, how would you know? You wouldn't know, right?
Well, I know the real world.
Hmm?
I know. I want to capture the real world. So either I relax the principle of the identity of indiscernibles to something like weak discernibles, and then Chris will tell me that it's not sufficient, and some of my structural realist friends will tell me that it is sufficient, and I find this discussion now so complicated that I don't know what to think about it. So I can try to go through with take the principle of the identity of indiscernibles literally and say I can stipulate, I can start with whatever I want to start with, right? So I stipulate.
Okay, so it's by
I stipulate that the relation I want is such that it distinguishes the object.
Okay, so that's by stipulation.
Yes.
Okay.
And if it works for the world, then I'm happy to run away with my stipulation. And I think it works for the world. I mean, I don't know a case where you have to give an account of what there is in the real world, which obliges you to give up or to weaken Leibniz's principle of the identity of the indiscernibles. Because if my ontology is one of spatial relations, then the spatial relations can do it, and we always have more than 2 objects in the real world.
Even if there were numerically distinct points that would behave in the same way, you wouldn't.
No, I don't know whether numerical. I don't want, if I'm not forced, but I could buy into this, and sometimes I thought I should buy into this, but now I don't think that I should do so, that I could buy into numerical diversity as a primitive. But if I don't have to, I better don't do so.
Yeah, but
why should I have
to? By stipulation. It's not something that can be captured in the basic structure and relations.
No, it is in the definition of what the basic relations are.
Okay, they are such that they individuate.
Yes, I'm looking for. No, you see,
okay.
I'm going to look. I want to have a basic relation, so I want that relation to do a certain job, and the job should be that it individuates my object.
Okay.
And then, of course, the relation I put in, spatial distance, has to be construed in such a way that it does that job.
Yes. I went to a talk in the philosophy of physics once, and I was told that the famous Professor Esfeld did not like the wave function because he thought it was some kind of mathematical ontology of real physical entities. Then I go and read this paper, and I see that a configuration of spatial relation is a distance function. It's a function from pairs of points to real numbers.
Yes.
Then I was promised a meager diet, and then I have already swallowed uncountably many fat real numbers.
No, slowly. I'm not a Quinian. I mean, this is these old concerns by Hartley Field that by having real numbers, you're committed to an ontology of real numbers. Sorry, why? I represent these relations in terms of real numbers, but perhaps natural numbers would do, or that's a means of representation. So why, by using real numbers, am I committed to there being infinitely many?
If there are no real numbers, then there are no special configuration, and then...
No. The number is a means of representation. There are spatial relations.
I don't know what it means. It's a means of spatial representation. No, a real number is a real number. A real number is something that's added and multiplied. Philosopher of physics has this idea that mathematical entities are not logical free lunch. They're not. They're not. Okay.
I have two objects here, right? There's a distance between these two objects. I wanted three objects, okay? So the third one. Okay? You have an intuitive understanding of what the distance relation is, right?
Yes.
That's primitive. That's out there in the world, the distance relation. Right? And now you want to represent it. And what you have here is, what I need is a comparison, proportions. One distance is greater than another distance. So here. And if I give real numbers to them, I can do the comparison. But out there in the world, of course, are not real numbers.
So how do you give them real numbers if they are not real numbers?
But you see, the dog of my neighbor tends to bite my children, right? And the language, biting and dog, etc., does not bite. But even if I had no language, that animal would be out there still. So even if I were speechless and could not represent it, it would do what it does. So out there in the world are certain relations. Now I have to tell you what these relations are. Then I have to use language. I have to use numbers are useful to represent it. But I don't see that by using a means of representation, I'm committed to being realist, to having in my ontology that means of representation.
But certainly you're not using numbers, at best numerals. If you think that there is something which is a function and which associates the pairs of your...
He means numerals.
Yeah.
Numerals.
Yeah. But I mean, I have to say, if you refer to
numerals.
Yeah, if you refer to the paper, I've written the first section. The second section is written Antonio Vassallo, and we discussed this, and you may find Chris spotted divergences in it, etc. Okay, so yeah, right. You have the relation defined. It gives you the function. Yes, and then Then is this in your version? I wrote in the version I have here. I think it's the same as because this work in progress changes whenever. The fact that these values are real numbers does not smuggle in any infinity in our ontology of finitely many particles and hence finitely many different relations. The real numbers are means of representation that do not belong to the ontology.
Okay, maybe we should move to the next question earlier.
That was just a very short.
Sorry? Yes, what?
Point the microphone at the audience, just turn it around, you don't have to move it. Just
The audience? Sorry, the microphone? They sound what? Weak? Do you not hear the audience when they ask questions?
better than last time, but I think it should still be.
And where's the microphone? So
this is the microphone.
Okay, so we should speak. And there's the camera. So I should look at you or...
So just question of understanding. If spatial relation individuate bonds, why don't you have only spatial relation in your fundamental ontology?
Because it does not make sense to have relations without relata.
But how can there be relata which are not yet individuated?
Yeah, because the relation individuates them.
So you
That's the old debate about structural realism, and I mean, and some people want more from the relata, and some people in the UK, such as Stephen French and James Ladyman, want less. But I don't understand. I don't understand how you could have. I mean, the formalism here goes: you define your objects, and then you put certain relations, you put a structure on these objects, and if you take away the objects, you don't have a structure left. It does not make sense. You
think that for a spatial relation to hold, there already has to be two objects, then the spatial relation does not individuate the object.
Of course, there are the spatial relation, of course, individuates. So you have 2 points. Now, no, you have 3 points, right? You put them in spatial relations, then you have meta points. You put them in relations of closeness to God, then you have angels being close to God. You put them in thinking relations, then you have Cartesian minds.
You are explaining not how spatial relations individuate points, but how they materialize points. So even that is weird, because you have kind of abstract points, and somehow the spatial relation get them from the sky and bring them to Earth. But let us agree with that. It's not individuation, it's materialization.
No, it's individuation, because it distinguishes each point and them. And if I were to take away the spatial relations, I would have nothing left.
You just say that you have 2 points, so they are already distinguished.
No. I mean, that's the old issue. Vincent Lam and I work on this. So in these old papers, and I still think it is true, our claim was that relations and relata are mutually ontologically dependent. It's a symmetric relation. You cannot have the one without the other.
And the idea is that they're individuated structurally, so they're places in a structure, these objects.
That I get. I mean, I would get your point if you have only spatial relation, a big structural spatial relation that individuates the nodes in the structure.
Yes.
In that case, it's all what you have basically as a spatial relation.
No,
you don't
because there are relations between relations hold between something. You cannot have. I mean, I need 2 categories for my ontology: objects and relations. And I should better not call the objects substances, although I don't like the word objects. Because substances you can be very strong about substances like Spinoza, that they are independent of each other, and then it's by definition excluded that relations can be essential for the substances. So call them objects for lack of a better term. But this goes together. Ontologically, they are one and the same, I would think, but there are 2 different categories, and you cannot dispense with one of them without thereby also dispensing with the other one. Or again, the burden of proof is on the camp of those radical structural realists. They have to change first-order logic to start with. I mean, there are many people around the world. The moderate ontic structural realism has gained a lot of allies in recent years. One of them you'll have week after next week in Chicago, Carrie McKenzie, etc. So there are many people. It's not that I'm alone in the world to say that you need relations without relata or structures without objects. Does not make sense.
Is this a finger?
Oh yeah, no, I forgot, no.
Otherwise, I
forgot
think
the convention.
it's Alex's turn.
He
had his hand up long before me, so maybe.
Oh, did he? Okay.
And I have a feeling it's going to be similar to the question you
I
asked.
don't know, so you can
Go
show
ahead.
the question. Well, I mean, I'm just, so, I don't know, let's see if I understood correctly. So you just have matter points, which are points. Actually, you have just particles that are all, and they're intrinsically all the same, they behave.
Yeah.
I read that Zanghi paper, which is strange. Like
What is strange? Sorry.
I read some Nino Zanghi and Dur paper in which you don't have distinction between particles.
Yes.
That's
Nino
the,
is.
and you have these
I like
points.
Nino. Yeah.
Yeah.
Okay.
I
So
was guessing. Yeah.
if what he
then
says
you
is
have-
strange, that's
No,
what
it
I
seems
say.
strange to me.
Yes.
Yeah.
Okay.
And then you have the spatial relation. So here's 2 questions. So do you think you can actually define or get all the other relations we seem to have in the empirical world, which we all know? So you're going to get, let's see, dependence relation, you're going to get causal relation, you're going to get particle relations, you're going to get topological relations of connection. How in the world? It seems like a lot of homework.
Yes.
Right?
Yes.
And did you do that? I mean,
Partially.
yeah, but
You should give me more funding.
No,
I
sure,
should
sure.
hire you
Yeah,
to
no,
hire
no.
more
I mean,
people.
you go have
The
fun,
homework
guys,
will be
and
done
I'll
more
be
quickly.
after.
Yeah.
It seems strange, like, so you have just point, I understand it, you don't have space,
No.
And you want to see, and you're gonna get me a recipe to
Yes.
tell me
Okay.
that this
So
thing
I
is
can
part
take
of
rescue, although I'm not a Humean, for the sake of making my life easier as far as that business is concerned. I can take rescue to Humeanism. You have the Humean mosaic. That is the points and the spatial relations between the points. Think of David Lewis. Just wipe out the qualitative intrinsic properties at points about which Lewis talks in his thesis of Humean supervenience. They don't do any job for the theory, so just cut them off, right? Then you are left with points, let's say sparse points, and relations between these points. These relations then come out as internal instead of external relations, right? That's your Humean mosaic.
Well,
now let this change these relations.
Yeah,
Then you can bring in causation in a Humean way. You can define configuration. So what was this extended objects in that way?
I don't know. I mean, I don't know how. In Lewis, for example, you have fundamental particle relations. That are
But slowly. You have real physical relations. The spatial relation is a real physical relation. Now, if you have a configuration of that, then you can have sub-configurations. You just take a proper part of the spatial relations, and that would give you a subsystem. Why should that?
I don't see what it means proper part of a spatial relation.
No, you just that your universe is one of. Yes, you just figure on that, focus on that. That's the world, that's configuration, right? That's too complicated for you, so you just focus on that. It's a sub-configuration. That's the whole system, that's the subsystem. That's the proper part because I cut off for the purposes I'm interested in the rest of these relations and just focus on free particles standing in these relations.
Kevin would like to jump in with this one.
So this is really just going further in the direction which is being taken. In your basic ontology, you have partless points.
Yes.
And you have spatial relations.
Yes.
Most of us think that relations don't have parts. So you have two entities, neither of which have parts.
Yes.
You want funding in order to show us how to get parthood out of what does not and cannot have parts.
Yes, because I have a configuration. Once I have at least three objects, that at least three relations, I have a configuration. And now I have a total configuration. And then I don't see why I cannot, if I have a configuration, say, of n particles, let it be 12, why I cannot just pick out 6 of them and focus on the spatial relations that there are among these 6 and neglect the rest.
Okay, so maybe I missed something. I didn't hear any reference to configurations during the talk.
There should have been a reference. Yes, sorry, but there was, at least in the slides. Sorry if I slipped this. So the world, the universe, what there is a configuration with at least 3 point particles and the spatial relations between them. So you have a configuration defined by a finite number of meta points and the spatial relations in which these stand. And now you can, of course, have a sub-configuration by just focusing on a subset of these n meta points.
Alex.
This is about the last slide. I guess I was confused. So one move to go towards in the relativistic setting is to say, oh, actually, it's not points and spatial relations. We need to go in for points and spatiotemporal relations. And then, but, I mean, your response to that is like, well, where do I get the distinction between variation and change? And my reply to that is like, why is it really important to get that, at least in our primitive ontology, the distinction between variation and change? It seems like the distinction between that is going to be something that you get by concentrating on specific frames of reference. So you're already, getting up out of the, you're getting up out of the fundamental level and asking, So yeah, my question is, yeah, why insist on, in order to preserve the spatial relations over the points and then privilege affiliation, why not just say, oh, well, it turns out the fundamental relations are not spatial, they're spatiotemporal. And
yes.
Just leave it at that. It didn't seem like you wanted to do that.
Yeah, because then I don't have change, and then I would lose
an empirical. But I don't see what fundamental physical work is done by, by change. You don't have a predicate. A special
yes, okay,
predicate
yeah, but then again,
say,
the burden.
Oh, and it changes. You just, you have the laws that you describe, and they just talk about variation.
Yes.
Time like,
yes.
space-like
yes.
direction. What?
Yes.
It seems like if you want to make a distinction between which variations count as changes and which ones don't, that has to do with like non-fundamental issue. Like how you get the tables and chairs and that sort of phenomena. It looks like certain sort of variations are changes and others don't.
But what is fundamental for what? I mean, the game is what is fundamental and what you need to be empirically adequate. So if you want to have change, it has to be change in something. Change in what? Change in certain relations. So you need them. So in the ontology you propose the change falls out. There is no change. It seems to you by making certain choices of reference systems, etc., but which are human choices for representation, they have nothing to do with ontology. You get change, but in the ontology there is no change. I feel a bit I'm too conservative now, perhaps. Yes, I feel a bit uneasy about that.
Yeah, I mean,
and I'm not for, and I would resist the claim to say that I'm forced by physics into that. Of course, a four-dimensional space-time geometry can be a very useful means of representing the change that there is. But you see, my uneasiness is that I lose the change.
That's precisely what I don't see. It seems like with points and spatiotemporal relations between them, you're going to get all the rest of the phenomena if general relativity is correct, including phenomena that we describe as change. If it doesn't,
you don't get them in your ontology. You get them.
You get it in your non-fundamental ontology.
No.
I don't see why you need to push that down into the fundamental ontology.
No. You impose a foliation on your space-time, and then you get it. But the foliation has what status?
Well, again, it has a non-fundamental status.
No. Either the ontology gives you foliation. That's the view I'm inclined to take, but the argument would then come from quantum non-locality. Or the ontology does not give you a foliation, and then it's whether it's like the language, whether you call the dog dog or chien, does not matter. There's nothing which is right in calling the barking animal a dog or in calling it a chien.
There isn't a privileged foliation, and it seems like it's able to explain. It seems like it's empirically adequate. So
there isn't a preferred foliation, but I did not get it what you said.
Without assuming there's a privileged foliation, it seems like relativistic theories are empirically adequate. If that's the case, if they're empirically adequate, well, they're able to explain change.
No, that's too quick. That's too quick. You have change once you have chosen a foliation. And then the question is, what's the status of that foliation? Is it just, does it have an ontological status? In that case, fine, then you have change in your ontology. But then you have a preferred foliation. Or it does not have an ontological status. It's like it's like, I find this chair comfortable and you might find it incomfortable, so you foliate your world according to which this object comes out as uncomfortable, and I foliate my world as it comes out comfortable, but there's no fact of the matter whether the chair is comfortable or uncomfortable.
So I should say that I'm with Alex on this one. I would think that there's maybe not conclusive, but pretty good reasons from the physics to try out an ontology, a fundamental ontology of some things, whatever we call them, particles or something, that stand in spatial temporal rather than temporal, spatial relations that change over time. And then the change we will get at some level non-fundamental. And whether or not that's in the ontology then is connected to another question I had, and now I'm moving away from your question, if you let me. So the idea is that the dynamics and the geometry and all the, maybe economic theories about how central banks operate and whatever when they do quantitative easing and all the theories you could possibly have that are somehow coming out of this and one way or another would not get us any ontology, right? That's what you seem to have been saying. That is, we're not committed to any of the things that these non-fundamental theories quantify over. That somehow, because they're all reducible to the basic spatial configuration, the change over time, and that's the only thing that there really is.
There are two points in this. The first thing was about the dynamics. So if Einstein is right, if you just have local dynamics in the sense that if you want to know how something will move, you just have to consider something in its backward light cone and perhaps in its future light cone, then the dynamics would not require foliation. In quantum physics, there are arguments for thinking that this is otherwise, but they are outside relativity physics. That's, of course, fair enough. What I would dispute is that you get change as emerging. Because if the ontology is one of spatial-temporal relations, there are no spatial and no temporal relations. And then not fundamentally. I want to see what does it. Okay, so just state the view. I'm skeptical about the view which says that you get change somehow out as non-fundamental. Then you would the fundamental ontology would always be one in which the change just is a variation, a difference in the spatial-temporal relations, and these relations do not change. Okay, the other issue is the one about reductionism. So if you say there are only particles in spatial that stand in spatial relations, you can have tables in your ontology, because a table is a certain configuration of particles, a chair is one. So there would just rely on well, science should tell us this, on molecular biology for life, on neurons, neuroscience, etc. This is, all this reduction in the sense of an ontological reductionism does not mean that these things do not exist. I mean, they figure in you can do this a la Lewis, Ramsey sentences, they figure in your description, you define how to define the new terms, you define them in terms of there's something that fulfills a certain functional role, and that functional role is realized by a configuration of particles. So it can be there. Whether this is exhaustive then depends on the question whether there's emergence in the sense that you have evidence that your fundamental physical laws break down. So if you have classical mechanics, you just have variables such as potentials, masses, etc., giving you a potential, and that's it. And perhaps when the system is so complex that it's an economical system, you need additional variables in the dynamics. So, or when the system is such that it is a mind-brain system, you need a mental force in addition to the gravitational force, perhaps. But then the point would be either the emergence issue, either what emerges is epiphenomenal, then it's not interesting, or it plays a causal role, then the basic causal laws are false or break down when you come to these complex systems. And then you need some evidence for them really breaking down. That's the causal exclusion or the causal completeness argument of physics. And I don't know, that's an empirical question. But perhaps when the systems are complex enough, Newtonian physics, if you suppose that Newtonian physics where the fundamental physics breaks down, and you need a mental force. People thought you need a vital force, you don't need it. But with the mind, I don't know. Or with economics or whatever.
Yeah, but I'm a little bit confused because earlier you said that there are no forces and there are no wave functions.
You need additional, yes. That's not the issue now. You need, no. The game was, you have this change in your configuration of matter. Now you find variables that describe this configuration. Okay, I shall be more precise now. Now it may turn out that you cannot succeed, that in certain situations these physical variables don't do the job, and you have evidence for thinking that other entities than just particles in motion come in. And then of course but the claim was that all physical theories can be captured in these terms. The Humean mosaic is the spatial relations, the change in spatial relations, you have the whole history of that change, then you fix the variables that give you, that are the most simple and informative description of that whole change. And now it may be that there are non-physical, that there are thinking minds of Descartes intervening somehow. Then you would have to enrich your ontology and you would have to write down other laws. But for the time being, I guess we don't have any conclusive evidence for that. But I'm not committed. I mean, this was physical ontology. It may be that emergence is true, but you should be clear about what emergence implies. Some non-trivial dualism.
I think Nick seems to have a point or a question.
Yeah, so this just think to touch on something else that I wanted to ask about, which was, do you think? I mean, so here's a. Let me give you a gloss, and then you can I'll just say where I think it takes us, and then you can tell me if the gloss is wrong. So, say our experiments involve, particle, pointer positions, whatever, brain states. All of that comes down to positions and motions and particles.
Yes.
Okay. Look, anything that I add to the ontology beyond that is going to make things more complicated.
Yes.
Everything is, by the premise that everything can be cashed out in those terms. So none of that makes adequate. It's going to be sufficient for adequacy as long as I can get the laws right. So what could ever make me think that there was anything more than that? I mean, why haven't we just done at that point? Why worry about the other laws? If they don't end up getting the pointers in the right places, then they're not empirically adequate, so we don't want them.
Yes, they should change the pointers' positions, right? But you can worry about this. I mean,
but if they get the pointers right, then I'm just going to be instrumental about them.
Yes.
But why do I even care what they say in detail? Why is that even an issue? Why isn't this just purely, given the premise that all measurements come down to positions and motions of particles? Why aren't I just done? Why am I actually interested in any of the other physics? Because whatever it says, I'm just going to say, well, it's an instrument. Right? It doesn't fit.
Yes, but if you put it that way, I'm instrumentalist also about the fundamental variables such as masses and charges. Okay? So I'm instrumentalist also about these variables. Well, the claim only was that pointers position, pointers motion is all the evidence physics give you. But you have more than just physical experience. You have your experience, you have the qualia arguments, you have these experiences that I have not made any claim about these experience qualia being covered by pointer positions and pointer motion. I just don't know.
In the physics direction, why do I care about having said this, why do I care about the details of physics at all? Why should, what you said about just got to get, all my physical theories have to get the pointers out. Beyond that, why is there any kind of constraint at all on what the physical theories say? Why is there any issue to look at all?
Because that's always a package deal. The particles in the ontology I've proposed are, of course, theoretical entities. You don't see those particles. They come in as the theoretical entities, as the proposal for the best ontology for the experimental evidence that you have. So you have to see whether you get the experimental evidence you have right with that ontology. So you better look into the physical theories if it can work. And earlier we had a discussion whether it can work for quantum field theory. And if it could not work, it would worry me whether it can work for whatever.
That's just the question of it. I mean, if the theories, given the empirical basis, it's all cashed out in pointer positions.
Yes, but the pointer positions could be field configurations. I mean, the pointers you see in the laboratory are macroscopic objects. What you see is discrete, etc., so it gives you evidence. I would say what you see is particle evidence, so the easiest explanation you should try would be an explanation in particle terms. But of course, people come up with saying they have stuff in their ontology. Instead of having discrete particles, they just have one stuff, as Thales had water or so. And perhaps a stuff ontology or field ontology, if it has the right dynamics, can tell you a good story about the laboratory evidence. And if this story is better than the story I've told you, then I should give up my story. And so I have to know what the empirical evidence is and how to best account for these particle positions and particle motions. And perhaps some people come up with other evidence someday. I mean, they make claims in that sense that they have other evidences. So you should look into this.
So, I mean, it comes down to then the empirical basis may not be completely captured in terms of particle positions and motions.
I would say that for all the experimental evidence I know and that we have, it can be put in terms of pointer positions or in terms of particle positions and particle motion. But it's not the claim that this is necessarily so. And then the second issue is how do you best explain this? And the fundamental ontology may have something else than discrete objects.
We have a couple more minutes.
Yes, but no more.
So trying to understand your picture, it's basically this. You say that those individual ontological points, they are in themselves kind of the thing that makes one of those a certain particle, like a proton or that's not proton, like positron or an electron. It's just the way it moves.
Yes.
So it's not that this has that type. This is a proton or is a positron from
Yeah.
the stock. It's just that. And then you have this, and the fundamental ontology is just these kind of spatial relations connecting all these little things.
Yes.
That is purely mosaic. Then you try to just construct the best law to describe how that thing works out. And then you identify some as positrons or electrons in that kind of theoretical framework to capture or predictions. Is that a correct description of your view?
Yes, they move, you have evidence that things move differently. And to give a good description of that motion, you call them electrons and positrons and what have you. Yeah.
So then I don't misrepresent you by saying that.
Sorry, I did not get...
Well, I don't so my description will basically correct description of how we think of that. Now comes my follow-up question. So, especially since you at least seems to be attracted by a presentist view as well, and you have that kind of previous story, there is no underlying fishy disposition or metaphysical horrible things underlying choosing what happens next. Why would you care? Why would you think something that had behaved positron-wise would continue to do that?
Yeah, it does not have to do that.
Yeah, so basically why do you trust anything?
Yeah, but that's the, I mean, I'm a dispositionalist in the sense that I think there is some modal structure in the world out there, at least I tend to think. But that was not the issue this afternoon, but to this question, I mean, you would give the Humean answer, just science works by induction. That's the best guess or conjecture you can make.
Then you have to read Caso's paper explaining why induction is a worse problem for the human.
Okay. Yeah, but that's, yeah. As I said, it's just convenient to set this ontology out in terms of Humeanism. I would tend to think that this configuration, there is a dynamical structure which we seek to capture, which is out there and which determines the way in which this develops. But this, to cash this out, it's another story again.
Okay, thank you very much. Thank you, the speaker. Thank you.